Okay, so considering that the screen was frozen through part of the lecture and I got stuck on a stupid programming problem, I'm just starting the lecture over. So for those of y'all who are watching the video, just understand that we're leaping right into the middle of it. So that's okay, because we've kind of already have talked about this stuff due to my habit of lecturing ahead of the material, right? So here's just another example of a for loop, right? Except it does something kind of silly according to a counting game that you can, sit around, with a group of kids and make them say fizz or bin, depending upon the rules. If it's evenly divisible by 3, they have to say one thing. If it's evenly divisible by 5, they have to say something else. And if it's evenly divisible by both, I think it's 2 and 3, right? If it's an even, well, that would be like every number, right? Evens and let's not do that. So we leave it 3 and 5. And otherwise, if we don't say any of the silly words, then we print out the actual number. And so a while loop and a for loop are pretest loops, whereas a do loop is a post-test loop, meaning that the test happens after it. So you use a do loop if the body must execute at least once. You use a for loop for definite loops, for counting loops. Otherwise, use a while loop. Now, there's another syntax for as well. In some languages, it's called a for each loop. I don't recall if this book calls it a range-based loop or a for each loop, but if you define something like an array, I'm going to define an array of numbers. That. So now I have an array of numbers. It's just a series of numbers, right? That is number index 0. That is number index 1. That is number index 2. That's number index 3. That's number index 4. So we could use a counting loop to get a hold of those numbers, right? For int I, short for index, is equal to 0. Keep running while I is less than the length of the array. Just this once and only once, I'm going to hard code the length of the array. I'm going to say const int, well, this is not a bad way, num underscore length equals 5, right? And I'm going to put that in here so that we know how long the array is. And the reason we're doing that is that unlike Python and unlike Java, you can't just merely ask the array for its length. There's no len function that'll tell you the length of the array. So you have to do it one of two ways. One is you can calculate the length of the array by doing some division, and the other is you could just set it up like that. So anyways, we're going to start off I is equal to 0, keep running as long as I is less than num length, and let's print out. Firstly, let's just print out I and watch it count, right? Because we want to see it count 0, 1, 2, 3, 4. That'll make us feel good. And then let's actually make it print out the values of the array. And I've apparently got a syntax error because there's a red thing there. No, it actually worked. All right, so it printed out 0, 1, 2, 3, 4, right? So let's actually print out the value. Numbers subscript I. So to print out 2, 4, 8, 16, and 32. And so it did. No, it didn't. It printed out garbage. What are these funny numbers it's printing out? Oh, I put this inside the fizzbin loop instead of outside of it. But we're still seeing these weird things. Apparently my computer just woke up on the wrong side of bed, or I did. Printing out an array is the simplest thing in the book. I can't believe that that is failing. This is supposed to be initialized to 2, 4, 8, 16, and 32. Let's just print out one of those and see if that's the case, right? Numbers subscript 0 equals end quote, less than numbers, subscript 0, less than ENDL. Let's just see if we can get a 2 there. I'm going to go ahead and cut this out because I just want to see some good output for once. No, it's got that garbage in it. Why is that? Oh, because I said character, and these are ints. Somebody already noticed that up in the chat. Yep. Thank you, Anna. You got it. These were ints. So it was printing out ASCII characters. I should have recognized that more quickly. Thank you, Anna. All righty. So there we go. It's going to print out 2, 4, 8, 16, and 32. That's one way to print out an array. And of course, since there's only one line of code in the block, I can remove the curly braces. Or I could do it like this. For every int that's in the numbers array, so for value colon numbers, in C#, you'd actually write the word for each there, and you'd put the word I in here. I kind of like that for each int value in numbers. In this one, you don't put that word there, and you don't put the word each there. Kind of more like Python. There you go, and you can just see out that value. So if you've done Python programming and you've used for loops, the kind where you don't have the range keyword when you're printing out the elements of a list, it's exactly the same thing. So this syntax, you might think is a little cleaner than this syntax. I certainly do. I prefer this syntax when I can get away with it. However, there are times when you can't get away with it. The only time this syntax works is if you're in the same context that the array was allocated within, the same pair of curly braces. If you're inside another function and you pass this array to a function, it's not going to work. You'd have to follow up. You'd have to do something like that instead. So you can have multiple expressions in the initializing part, right? X equals 1, comma, and Y equals 1. We could have one of them count up and the other count down if we so chose, right? So for int X equals 1, comma, Y equals 10, semicolon, and keep running while X is greater than or equal to 1, semicolon, and each time we're going to add 1 to X, comma, and we're going to subtract 1 from Y. And so let's see out X followed by /T for tab, end quote, less than Y, less than ENDL. And we'll see X count from 1 to 10, and we'll see Y count down from 10 to 1. Or not. I must have my while condition wrong. Keep running while X is greater than 1, and that certainly is what it's doing. My brain slipped for a minute. I thought what X was going to be counting down. It's counting up, so we need to do that. Right, and then it counts up. 1 to 10, 10 to 1, X and Y. You can also leave parts of these off if you want. I'm going to take the same loop, but I'm going to paste it again after making a modification to it. If I wanted to, I could do this step before we go into the loop, right? I just cut it out. And so now we have nothing before the semicolon, and that's okay. That would work just fine. It's going to work the same way. So we're going to see that output twice now. 1 to 10 and 1 to 10. You could also leave this part off if you wanted to. You don't have to have an update in your for loop. Something had better change the values or else it's going to be an infinite loop, but you could do it like this. Better set X and Y equal again. Right. But we don't have to do this here. We could cut this out and just like put it right here, right? Add 1 to X each time and subtract 1 from Y each time. That works. And if you want a loop to run forever, like a while true loop, then you could remove this condition. For int z is equal to 1, z++, and we're going to see out z. We're going to add, but if z modulus 20 equals 0, right, then we're going to break out of the loop. Again, this is an absurd way of doing it, but it's like a while true loop, right? Leaving that out. Or the silliest example of all is just doing for and nothing in there, right? Like that. That is the exact same thing as a while true loop. So you can subtract 1 from 10, from x, print it out, right? And then if x is no longer greater than 1, if it's less than 1, then we break out of it. Absolutely, by the time you start doing monkey business like that, you should have just written it as a while. If we look at it, I was expecting it to count down from 10 to 1, and I'm not sure it did. Yeah, it did. It did. There's just no breaks here to make it easy to spot. Along with break, there's also the continue keyword. And whereas break causes it to go to the bottom of the loop and exit, continue causes it to go back to the loop and iterate immediately, like this. Let's go ahead and do an ENDL there just so that our output's got a blank line somewhere in it. And then let's do another counting loop. I is equal to 1, keep going while I is less than or equal to 10, I++ each time. Let's see out I. And then we're going to have a statement here that if parentheses I is equal to 5, we're going to continue. Else we're going to see out something else. And so what we're going to see is it's going to print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But when it hits 5, it's going to immediately continue. So we're not going to see the question marks. Every other time we will see the question marks. So 1 question mark, 2 question mark, right? 3 question mark. But when we hit 5, the special case, it continued, meaning it went back up to the top of the loop immediately. It did not do the question mark. And so that's why it goes from 5 to 6. So you can use continue to cause the repeat of the loop to happen early. Whereas you can use break to cause the loop to exit. So like if I is equal to 7 or 8, then we'll just break. Not silly, since we told it to keep going while I is less than or equal to 10, but it'll just prove the point. It's going to print out 1 through 8, but on 5, it's not going to print out the new line. And on 8, it's going to exit. And that's what we see, right? 1 question, 2 question, 3 question, 4 question, 5. No question marks because it'll continue. 6, question 7, question 8. And since I was equal to 8, it broke out of the loop. So let's add to our notes. Break causes execution to exit the loop, or the switch case, right? Continue causes the loop to repeat instantly rather than execute the rest of the body of the code. So what might you want to use a continue for? You might want to do some data entry, and you want to keep asking them to give you a good value, and you're not going to let them actually enter the data until you get good data, right? Another score entry loop, you know, enter a score or -1 to quit, something like that, right? So let's do a loop that says, do you wish so while true, let's declare our input variable, int input is equal to 0. And then let's tell them what they need to type in. Enter a positive number or -1 to quit. First thing we're going to do is just check to see if they typed in the -1. And if they did, we're going to break. So let them type in their input, CIN greater than input. And then we check, is the input equal to -1? If so, let's break. Now we're going to validate it. Oh, I made a newbie mistake. Look at that. I put a semicolon there. All right. So we validated it as not a -1. If it was, we exited the loop, but we want to make sure that it's a positive number and not a negative number. So it better be greater than 0. If the input is less than or equal to 0, then we're going to see out an error message, right? Error, invalid input. And now that we've done that data validation, we're good to go, right? We could do whatever we needed to do with a number. See out their input followed by the word squared equals followed by, you know, POW input, (2). And I need to go and get the rest of my boilerplate because now I'm using math functions and stuff. So I should have done this right from the beginning. Go and get the boilerplate. Using math defines, I'm just going to go and grab the whole thing. Well, we don't really need the whole thing. Let me get the shorter version of it. All right, so there we go. Right. I just did that so that even if I was programming this like on Linux or, you know, some other compiler other than Microsoft Windows, I'd still have the POW function available to me. All right, so enter a number. Okay, how about -2? It yells at me, error, invalid input. but it didn't yell at me. I have a mistake. I forgot to put a continue statement here. I wanted to tell them that it was invalid input, and then I wanted to continue immediately. So will not do the rest of the loop. Does that make sense? Once we detect an error state, we're just going to repeat immediately because there's no reason to keep going. That is one way to do it, and it's not necessarily the best way to do it, but it's something to have in your toolbox. You know, you can force yourself to reiterate the loop immediately rather than process the rest of the loop. So you can put multiple statements in the initialization. This says that you can have multiple statements in the test expression. However, that's not the test expression. This is the update expression. So it's like the slide is wrong. Can you actually do it in the test expression? Like if we do this, let's do another ENDL here just to visually break up our stuff. So I'm going to do that same business where I set X equal to that and Y is equal to 10. And I'm going to, well, I guess I could have done that inside the for loop, right? Let's do that instead. Put those two declarations in here. Although the variable's already defined, so I'm just going to reinitialize them, right? X is equal to 1, comma, Y is equal to 10. And it said that our test expression you can have more than one of them. Like keep running while X is less than 10, comma, Y is greater than 2. I would never do that. I would just make it an and, right? And an X plus plus, comma, Y minus minus. Apparently that's good code. Let's make sure though. Let's see out X followed by a tab, quote, backslash T, end quote, backslash ENDL. When is it going to stop? It's going to stop when Y is no longer greater than 2. All right, so enter a positive number. I'm going to be stubborn and not. It says invalid input. Now it's waiting for its input again. I'm going to type in a number. Great, 10 squared is 100. Now I'm going to enter -1, so it'll quit. That is my so-called Sentinel value. Remember that. Sentinel value, that's our Sentinel value there. And then it counted. Oh, I didn't print out Y, so we didn't see it. But notice that X did not actually reach 10. It's because this condition became no longer true. So that works, but I would never do it that way. Because I would just replace that with an ampersand and it becomes more readable, right? That's how I would do it. Note the above code will exit when X is no longer less than 10 or Y is no longer greater than 2. But I would write that with an and. Not like that. Hope that makes sense. Spacing is always an interesting consideration. How do I make this code as easy to read as possible? I think that's actually easier to read than what it was before. Removing some of the white space, I actually think it's making it easier to read. I'm not sure about that, but I think so. Yeah. I'm going to change that word not like to rather than, right? Okay, there. Enough cleanup. Go on. If you leave something out, then the syntax is still valid. You just better have initialized it beforehand. If you leave that out, you better have initialized it beforehand like we do here. If you leave that out, there better be a break statement in it. And if you leave that part out, then there better be some kind of update inside the loop. And again, if you're going to do all that, why not just make it a while loop? You can declare variables, and that's how I always demonstrate it, right? You don't have to, but you can declare your variables either inside the loop initialization step or above. You could do this, right? You could declare that variable there and then just initialize it here, or you could declare it initialize it at the same time, which is usually what I do. Keeping a running total. We've gotten several examples of this already, right? Create a variable called sum, and then keep adding to sum, right, until the condition becomes false. This would add up all the numbers between 1 to 10. So initialize your accumulator to 0, the sum variable. Is there a number? Yeah, read it and add it to the accumulator. Otherwise, go on your merry way from there. So this program takes daily sales amounts over a period of time. Well, that's just like the score example, except they ask for how many days do we have sales amounts, right? Get the number of days. See out less and less than for how many days do you have sales amounts? They type in like 5. And once we know how many days, because they typed it in, we have a for loop that counts that many days. We get the sales, and then we add it to our total. Sentinels. The Sentinel is a value that indicates the end of data. And when you do this, it needs to be a value that cannot be confused with valid data, right? So that's why I use -1, because I'm never a big enough jerk to give you a -1 on a quiz, right? So they're saying use -999 as your quit value, as your Sentinel value. You use it to terminate when the user may not know how many values will be entered. Because there's 2 ways to do that, right? You could say enter a value, and then you could ask them if they wish to continue. You could say enter another value, and then you could ask them if they wish to continue. And you could keep doing that, right? Or you can do it in 1 step rather than 2. So sum equals 0 while true CIN or cout very number to add CIN that number, add it to our sum plus equals, wait, that was supposed to be a value, right? A value variable. We add that to our sum, and then we ask them if they wish to continue, right? So let's declare a value called repeat, string repeat. Let's ask them to type in Y if they want to repeat. Cout, do you wish to repeat or continue, right? And then we let them type that in. And then if repeat is not equal to Y, then we break. So I guess we better tell them that that's how they break the loop, right? So we put Y/in there. And suppose we want to keep going and let them use lowercase y as well as uppercase y, then we want to do if repeat is not equal to y and repeat is not equal to lowercase y, right? Like that, then break. So when we ran this, if we do, enter a positive number, okay, fine, -1. I'm just going to exit that earlier loop, right? Enter a number to add 10. Do you wish to continue? Yeah, I do. Enter, add another number. Do you wish to continue? Yeah, I do. Enter another number. No, I'm tired of entering data, right? So I was having to type in 2 things for each piece of data. That's kind of tedious. I guess I could output the sum, right? Cout sum so far equals sum, right? Just like that. But I could simplify the loop by just using a Sentinel value instead. So I'm just going to copy and paste, but change it to say enter a number to add or -99999 to quit, right? And so then they type in that number, and we're going to have an if statement. If the value is equal to -99999, then we break. Otherwise, we add it to the sum there. Yeah, just like that. It's a little bit shorter, actually, right? It's at least 1 line of code shorter. We're not having to create a new repeat variable, although we could have done that ahead of time, right? And I guess we could have done this, right? String repeat equals quote y, and then keep going while repeat equals uppercase y, or repeat equals lowercase y. That's more classical computer science. That's how the book would show you how to do it. That way we can get away with a break statement, right? Like that. Forgot my semicolon. All right. And if we're going to go to that effort, then why don't we make this one look good too? So while value is not equal to -99999, then we'll just say if value is not equal to -999, add it to the sum. So I need a curly brace here, and I need to indent these next 3 lines. Add it to the sum. I don't need a repeat variable anymore. Display the sum. Right, like that. Okay, so that's just 2 different philosophies, right? One is asking them if they want to repeat. That's called user query. And the other is using a Sentinel value. So those are called loop termination techniques. The Java textbooks calls it out a little bit more specifically, but it uses this terminology. Loop termination techniques. 1 is just counter based, right? You're going to count from 1 to 10. 2 is user query. Ask the user if they wish to repeat. And then the 3rd is a Sentinel value. Am I spelling Sentinel? Yeah. Well, for one thing, I forgot that. Another is I may be putting, yeah, an A rather than an E. Okay. And so what is a Sentinel value? A Sentinel value is a value that ends a loop. Should not be a valid piece of data, right? Example, enter test score, -1 to quit. And in that case, what is the Sentinel value? It's equal to -1. All right, gang, we've been at this for about an hour, so why don't we go ahead and pause and come back at 8:30. So I found it was actually fizz buzz, not fizz bin, according to that programming problem I was looking for. Fizz buzz is a very simple programming task asked in software development job interviews. And there's all sorts of ways you can do this, and they can get inordinately complicated. I like my solution better than theirs, but print 3 instead of fizz, print 5 for buzz, and you're supposed to print fizz buzz if it's both divisible by 3 and 5. And here's their answer, right? If it's divisible by 15, they check that first. And then they use else if divisible by 3, they print the other one. Else if divisible by 5, they print the third one. Else the last choice. And that is one way of doing it, right? I kind of don't like that way because you're checking for this condition twice, right? You're checking to see if it's evenly divisible by 3 twice. You're doing it kind of in there and in there. This is a perfectly valid and perhaps the cleanest implementation of it. Mine was a little bit more complicated because what I did is, where was that? You need to change that to buzz, right? Fizz buzz. Right. Anyways, so I set the string equal to that, or I set the string, or I add that to the string, or optionally add that to the string. And if the length of the string is 0, then we just print out the number itself. Otherwise, we print out that string. Same idea, right? There's really nothing magical about it. Either way would work just fine. So Sentinel values we've talked about, and we've been using them several times. Enter the number of points your team has earned so far in the season, enter -1 when finished, right? Eventually they enter -1, and so we say the total points are 34. Deciding which loop to use. The while loop is a conditional pretest loop, so it's great for when you want to iterate as long as a certain condition exits. It's good for validating input, reading lists of data terminated by a Sentinel. So I think I had a question about doing a data validation loop. I think that we had that in homework and somebody wanted another example of that. We had one in there already, but I want to do another one, right? So let's go ahead and write a loop that does a data validation, but not using continue, right? We're going to do just a little bit more of a traditional data validation. The do while loop is a conditional post test loop, so it's good for when you need to iterate at least one time. And the for test is a pretest loop. It's great for built-in expressions for initializing, testing, and updating. For situations when you're stepping through an exact number of iterations, when you're stepping through a sequence of values or data, that's the best loop to use. All right, so we're going to rewrite this loop here to where we ask them to enter a number -999 to quit. I'm just going to copy and paste the whole thing, and I'm going to add, let's add some comments as to what's going on here. Data entry with a user query asking if they wish to continue. That's what this was. And the next one was data entry. A Sentinel value to allow exit from the loop. And then this is going to be the same thing, right? Data entry with a Sentinel value. And showing data validation. And so what's our data validation going to be? Kind of the usual. Enter a non-negative number to add, or negative 9999 to quit, right? So we could have a loop here. This would actually be easier if we did it with -1. I'll rough it. I'll see if I can get this to work. So, while true, or while the value is not equal to negative 9999 and the value is greater than 0, right? Or greater than or equal to 0. I'm not sure that that's going to do it. I'm just going to make it a while true, right? So then we're going to ask for the value. And if the value is negative but not negative 9999, we're going to tell them it's an error, right? So just let them type it in, CIN greater than value. And if the value is less than 0 and the value is not equal to negative 9999, then that's an error state. We need to tell them that. Cout invalid error. Re-enter data. \n quote semicolon, else we're going to break, right? That's one way to do the data validation. And then once we're outside of that loop, we can check to see if it's equal to a negative 9999. And as long as it's not, we can do that, right? We can add it to the sum. And that's going to keep repeating while the value is not equal to negative 99999. I think that makes sense. There's other ways, but in general, if you ever get a valid piece of data, then you can break. We could rewrite this. If the value is greater than or equal to 0, or the value is equal to negative 999, then it's perfectly good data, and let's break at that point. Otherwise, let's display the error message, right? Same logic, just expressed differently. I'm not sure which one you like better. I kind of like that one better, right? We read the data in and we decide, and we immediately decide that it's good. And then once we exit the loop, we can test it to see if it's our Sentinel value. All right, anybody want a copy of this code as it is so far? I'll go ahead and paste it in the chat. All righty. All right. It should be there now. And we're almost done with the looping chapter. If we skip down to 80, right now we're on page 510, whatever that is. Skip down to 80, we will see breaking and continuing a loop. And we've talked about this. You can use break to terminate the execution of the loop. We've demonstrated that, but it says use sparingly, if at all. They say that it makes the code harder to understand and debug. I say that if you use it like we did here, if you use it in only one point in the code in the loop, it's okay. And if you use it inside an inner loop, it terminates that loop only and goes back to the outer loop. Well, what does that mean? I just demonstrated what's known as a nested loop. It's a loop inside a loop, right? This loop is inside here. You see how you can expand and contract parts of the code like that? This while loop is inside this while loop, so this is a nested loop. It's nested inside this one. And the break statement causes it to break only the inner loop. It's still inside the outer loop, right? Because as soon as it breaks out of this while loop, it's still in this loop, and we can check to see if its value is equal to -999. So the following code is an example of a nested loop. And so the continue statement tells it to go to the end of the loop and immediately repeat it, whereas the exit statement causes it to go to the end of the loop and then exit the loop. And it says use sparingly, like a break. It can make the program logic difficult to follow. All right, so now we're actually going to be getting to pretty much a new topic, which is reading from files. What is a nested loop? It's a loop inside another loop. For row equals 1, row is less than 3, row plus plus. And then for column equals 1, column less than 3, column plus plus, print out the row times the column, right? So we can do a couple of nested loop examples. Like what about a clock that's going to print all the numbers between 1 and 6, right? 1, 115, 130, and 145, something like that. We can do that with a nested loop. So for int hour is equal to 1, keep running while hour is less than or equal to 6, hour plus plus. And then the minutes, int minute is equal to 0, keep running as long as minute is less than or equal to 45, minute plus plus. And we're going to see out. That was supposed to be a for statement there. We're going to see out the hour. Let's just print out the hour, followed by a colon, followed by a minute, followed by ENDL. Now it's not going to look perfect because for 30, it's only going to print 3. No, it is going to print 30, but for 0, it's not going to print 0, 0, right? It's just going to print 0 a single time. And then we have 2 closing braces necessary. And it looks like this is the end of my code. I've got this for loop past the closing brace that ends the end of my program. Nope, I don't, but I'm definitely getting it wrong there. So this is the end of main, and I have one too many closing braces. I can drive you nuts trying to fix. So here's our nested loop example, right? It's going to display 1, 115, 130, 145, 2, 215, 230, 245, and so on. Or it's not going to because I have an error. Did I somehow lose my string definition again? Nope. Tell you what, I'm going to take this part off because it seems to be giving me grief. Oh, y'all see what's wrong with that? I've got single apostrophes there, and I've got double quotes there. Slot B. All right. So Victor, if you're using the code that I sent you, you're going to have to make that change. And I definitely have brace problems, right? So I'm going to highlight everything and do Edit, Advanced, Format. And I'm going to go and look and see if I can spot where my closing brace is missing. See here, this while -999 should have ended here. And then the for loop should be here, right? And then I could put, right, like that. And then this should go back one as well. There we go. All right, -1, 0, no, I don't wish to continue. Add a number to add, 99. Do you wish to continue? No. All right, I've got, my logic is wrong. Am I supposed to add, type in Y to quit? Seems to be an infinite loop. Let's go find out why. Nope, I don't get why it's an infinite loop. I'm going to change it to being a while true loop and do my break. Should have worked the other way, but it didn't seem to be, so I'm going to try that. -1 to quit, a number to add, 10. Do you wish to continue? Yes. Enter another number. Oh, see, now it bailed. So if repeat is equal to capital N or lowercase n, then break. But that wasn't a problem. It still should have worked the time before. All right, -1 to quit. Enter a number, 10. Yes, I wish to continue. 20. No, I no longer wish to continue. Enter a number to add. -9999. Wait, let's try out. Since this is the data validation loop, I need to test it with bad data. It did not reject -900, and it was supposed to, I think. No, it's probably the next one. Yeah, this one says a non-negative number to add, right? And so if I type in a negative number, it yells at me. Finally, I give it some good data. And then I type in -999 to quit that, and it prints out all the hours. Except I meant to add 15 to it each time rather than just one, because I wanted it to say 6, 6:15, 6:30, and 6:45. So I'm going to do that. We're getting to the point where we have to do so much data entry every single time we run the program that I'm not going to be running it very often. And yes, I definitely did need the double quotes. I wish I caught your chat messages before I stared at it too long. All right, so this one I'm going to make it minute plus equals 15 to do what I was trying to do there, right? And what if I really did want it to print out 2 zeros rather than 1 there? I would need to use formatted print statements in order to accomplish that, and I'm not going to try to figure out how to do that right now. We have something more interesting to talk about, which is file I/O. The ability to write to a file. We're pretty much done with loops, though. We could pretty much say that we're done with a chapter, but we got to talk about file I/O as well. Using files for data storage. You can use files instead of the keyboard, right? And the screen to do input and output. Why do you want to do that? So that your data is retained between program runs. Like this is a census year, right? And so if we were going to run, statistics on all the census data of Oklahoma, we would not have we would not want to have to type all that in, and then when we wanted to run another report, have to type it in again, right? Because there's, you know, millions of people who live in Oklahoma. So instead you would save all that data to a file or a database. So generally, what do? You open the file and then you use the file to read from it or write to or both, and then you close the file. And so there's a new data type required called fstream. Fstream allows us to do file I/O. There's several different types. ifstream lets you do input. That's what the I is for. ofstream lets you do output. Or if you're going to do both, a little bit rarer, I guess, you just use fstream. So to define your file, you use ifstream followed by a file name, or ofstream followed by a file name. And so you create your variable and then you call .open. And when you do that, it creates a link between the file name and a file object so that it's got control of a file on your operating system, right? So infile.open, inventory.dat, or outfile.open, report.txt. The output file will be created if necessary. That's true for when you're doing output, but if you're doing input file, if the file does not exist, it will just fail, right? Because it has to have an existing file name. You can't open a file if it's not there. And then testing the file to see if there's an error, right? Well, let's give some examples of that. Let's create an output file and let's try to save some data to it. So we need a new #include. #include fstream. And I'm going to put this stuff up at the top of the program because I'm getting tired of having to answer all those questions. So we're going to create a file. It's going to be an output file, so I'm going to call it fout for output file. Instead of cout for console output, it's file output. You can call it anything you want, right? That's just a variable. Now let's open the file. fout.open file name. Well, we need to give ourselves a file name. We don't have a file name variable yet, right? So string file name. I'm going to call my file name output.txt. And then fout. I'm going to call it lecture _I.txt. Make it maybe easier to find, maybe not, we'll see. So fout.open the file name. And then we need to make sure that it wasn't an error. We got to check to see if it was successfully opened, which is what this page is telling me. And you just do it with this syntax, if parentheses not in file, or you can use the .fail member function. I would prefer to do it like that because it makes it look better to me. fout.fail. Right, like that. Then we print an error message telling them that we could not open that file. Else we could do something good with the data, whatever we wanted to do. Print some numbers to it, I don't know. For int count equals 0, semicolon, count is less than 9999999, right? Let's write a lot of numbers to it. That's 1,000. It's like 4, 5, 6, 7. That'll be 10 million. Okay, let's just go out to a million. Why get overly ambitious? Count plus plus. And let's write that number out to the file. We don't want it to go to the screen, we want it to go to the file. So I'm going to use fout, the count. And let's let it go. All right. It took a little while. We don't really know how long it took. And I forgot to do something that I should, which is that as soon as you're done saving to a file, you need to close it. So I'm going to close the file there. And it wouldn't hurt, even though the file was not opened, I could put the F out close there so it's a little bit more obvious, right? So that it's outside of the if and the else, like that. Because you should always close the file. Because otherwise, the program will keep the file open, and it may have a lock on the file so that if you try to copy the directory to another drive, you know, you're copying your files to a flash drive or something like that, it might get an error. You might not be able to back it up or whatever. You've seen that kind of error before. You're trying to open a file in Word and it says you can't. Let's print out a little message when we're done saying that we did write the file, right? Cout file created, colon, end quote, followed by the file name, followed by ENDL. So it's taking a while, but it did it. File created, lecture_I.txt. Well, let's see if we can find that file now. I'm going to just use the magnifying glass and type that in. I don't know what it just did, but it was not what I wanted. I did not mean to open Edge. Go away. I'm trying to read the news. All right, that's what I want, lecture_I.txt. And I'm going to open it with Notepad. And there it is. It's a million numbers. Now, since I forgot to write ENDL, it looks really lousy. So I'm going to add the ENDL to it. And again, the file was created. So let's open it up again.
I can learn to understand.
Oh, hush. All righty. And there they are, right? All million lines of data are in here. So writing to a file is pretty fast. It's actually faster than displaying to the screen, right? Because when you write to a screen, it has to actually scroll the user interface. So if I was going to display a million lines of text to the screen, it would have taken a lot longer than it did to write out those million numbers. So that's how you do file output. File input is just about as easy. Maybe we need more examples of that. Is one example of writing file output enough? Let's do another example. Let's ask the user for a file name, right? Enter the file name to save your data, right? And then let's read in the file name variable, and then let's open that up, right? OF stream output file, right? And then output underscore file dot open the file name that they typed in. And let's try to open it. So output, wait, we just did. Let's see if we failed. We could do it like this, like they show. If not output file, that's an error condition. Can also do if output file dot fail. That's my preferred way, but since the book shows this way, why not do that? Then we would need to display an error message. Could not open file, end quote, less than, file name, less than ENDL, right? Else we can write some important data out. Else cout saving data to file, right? And then whatever our data we were supposed to save is, right? I don't know what it's supposed to be, but output file, you know, less than Here is some data. Output file, lesson. Here is more data. Output underscore file, lesson. Well, that about wraps it up. And then we would want to close the file because you always want to close your file. So output file, output underscore file dot close. I like F out better, but I'd already used F out. So let's try to give it a bad file name. So I'm going to use a drive letter that I don't have, right? If I pop open my command prompt and I type in net use and I see all my drive letters, it looks like I don't have a drive M, right? So I'm going to try to tell it to save to drive M. And there is no drive M, so that should be an error. It's still doing those million lines of output, so it's taking me a little while. So each time yes. Every time I'm writing the program, it's writing over the existing data in the file. What if we wanted to append to it instead? Very good question. We will, I'll Google that up in just a second. Enter the file name to save your data, m:\output.txt. I'm going to use /. Doesn't matter. It'll take it fine either way. And it's going to fail either way because we do not have an M drive. And so we got an error message, right? Could not open file m:\output.txt. So it did not save our file. So sometimes you may want to append the data to a file rather than overwrite it. So let's look up ofstream append. How do we open a file for appending? That's a mode. So you can specify a mode. I need to see an example of that. Like that. Here they're saying it's an output file stream, which you really knew already because it was an OF stream there. But I guess it doesn't hurt to specify it again. But you can also say, I want it to be an OF stream : APP to mean append. Let's do that. When we open our file, we're going to open it. What's the syntax? It's just a comma followed by that. We don't have to put the standard : because we have that using namespace std, but it wouldn't hurt. So std : ofstream .app. Now it looks like I botched it because it's going to underline it. My short-term memory is not working long enough. Okay, ofstream : app. Open for appending. Let's try it out. Output file how about output underscore file.txt? That way I'll remember what it is and I can go and look for it. And hopefully it saved it. It said saving data to file. I forgot to echo the file name back out, but oh well, good enough. Now let's go see if we can find that file without doing a search for it. If I come over here and right click on the solution and I say open folder in File Explorer, I should be able to find the output file somewhere over here. Like maybe in the project. Here it is. I know you can't see it because of microscopic print, but it says output underscore file.txt. So I got to that just by right-clicking on it, doing open folder in File Explorer, and then going into our code, the folder with our code, and there it is. There's our txt files. And it says, here's some data, here's some more data. Well, that about wraps it up. I'm tired of waiting for it to write out 1,000,000 lines, so I'm going to change it to write out only 100,000 lines. Just remove one of those 9s. Let's run it again. Let's make sure it actually appends to it so that instead of 3 lines of output, we should have 6 afterwards. Output underscore file.txt. Let's go see if that's the case. Right click, open folder in File Explorer, open our source code folder, output.txt, and there it is. It opened it for appending. Okay, so we are going to have a little bit of homework. Here's what I want it to look like. Just a second, let me look something up so that I give you actually a good example. All right. So, I want us to write a program that looks like this. Welcome to the BMI calculator. Well, what does BMI stand for? It stands for body mass index. And it's a way that you can measure the ratio of someone's height to their weight in such a way that you can perform statistical calculations on it. So like they might say, okay, the population of Atlanta, Georgia has the average body mass index of this, that, and the other. So what do we need to do? We need to ask them for their height in inches and their weight in pounds, right? So what is your height in inches? 72. What is your weight in pounds? 200. Your BMI is 27.1. Now that may not be it exactly. I'm going to give you the formula for calculating BMI, and we can run it through there to see if that's actually it. Okay. To save your results to a file, please enter a file name. And so you type in bmi.txt, and then it's supposed to write data saved to bmi.txt, or just maybe data saved to file. That's how it's supposed to work. All that it has to write out to the file is your BMI is 27.1. Okay, so the formula for BMI is BMI equals 703 times height. I don't think that's correct, and I better look it up. I don't want to botch this. divide the weight by the height in inches squared. Okay. So 703 times the weight divided by the height times height, or height squared. Okay. So that's how the program needs to work. Obviously, it's not going to have that part in it, right? So you're just going to ask for these two pieces of data, and you're going to calculate their BMI, and we're going to save it to a file. Now let's see what 272 really are, right? Because I just know that it's about 27.1, but I want to test it for sure, right? So way up here at the very top, let's do that, right? Double height equals 72. Instead, we should ask for the input, right? This is just for sample testing our formula. Double weight is equal to 200, right? And so that's inches, that's pounds. And then the BMI, double BMI is equal to 703 times the height. I'm already botching it again. Times the weight. Yep. No, I was botching it. Times the weight divided by height times height, right? And then let's see out BMI. System parentheses quote pause, just so I don't have to see the rest of the program run. Let's see what it really equals. Okay, 27.1219. That's a bit silly, right? But that's okay. Let's go ahead and update 27.1219. Was that what that was? 1219, yes. It'd be better off to round it to like one digit or whatever. I know how to do that really easily in some languages. In C++, though, I would have to use the IO manipulators, and I don't want to, so I'm going to leave that alone. All righty. So that's the homework assignment. Does that make sense, gang? All right, I'm going to pause the share momentarily while I go and look at something in the exam. I will be right back.